Hello everyone, I'm Yash Narkade from TEB and today I'll be presenting my topic Residential Wiring Design, its IS rule and estimation. In this presentation we'll understand the design procedure for residential wiring, the IS standards that guide it and how proper planning ensures both safety and efficiency. Introduction to residential wiring design in India. In India, residential wiring design must follow certain IS standards like IS 732 and IS 3043. These ensure that every electrical installation is safe, reliable, and future ready. We'll go through how wiring is designed, installed, and protected according to these rules. Of proper wiring. Proper wiring is the backbone of a safe electrical system. It prevents hazards like short circuits and shocks, ensures voltage stability, and improves energy efficiency. Following IS rules also helps ensure that the system can handle future load demands without problems. So next is safety and efficiency consideration. Safety and efficiency are both equally important. Devices like MCBs, RCCBs, and fuses protect against fault and shocks. Efficiency comes from proper wiring sizing, minimal voltage drop, and balanced load distribution across circuits. Now first we'll see the design procedure fundamentals. So first is planning and coordination meetings. Before starting any wiring work, a meeting between the owner, architect and contractor is held. They finalize the location of switches, sockets, meters and distribution boards. This stage also considers future load expansion to avoid rework later. So next is load assessment and future demand. Load assessment means identifying all electrical loads in the house, lighting, fans, sockets, and appliances. It helps decide the size of wires, fuse ratings, and the number of circuits. Planning for future appliances ensures the wiring can handle extra loads safely. Next is wire system and circuit design. In this step, we design how the proper flow of power will go through different circuits. Separate circuits are made for lighting and power loads. Proper circuit design prevents overloading and ensures every section of the house gets a stable voltage supply. Next is circuit classification, lighting versus power. IS 732 states that lighting and power circuits should be separate. Lighting circuits handle up to 800 watts while power circuits can handle around 3000 watts. This division makes the system safer and more reliable during daily use. Now the selection of wiring types and conduits. There are three main types of wiring: concealed conduit, surface wiring and casing capping. Concealed conduit wiring is most commonly used in home as it's safe, protected and looks neat. The conduit material and thickness are selected according to IS 554 and IS 732, which we are going to see later. Now next is conductor selection and color coding. Wires are usually copper because it's a good conductor and has high durability. IS 732 specifies color codes red, yellow or blue for phase, black or neutral, and green for earth. Using correct color codes helps in easy identification during maintenance. Now civil work completion and wiring sequence. Wiring should begin only after the main civil work is finished. For concealed wiring, conduits are laid before plastering since they are buried inside the walls. Lighting and power wiring are laid separately to make maintenance and fault detection easier. Earthing methods and safety devices. Earthing is one of the most important safety features. It provides a low resistance path for fault currents and prevent electric shock. For single phase connection, one earth pit is used. For three phase, two earth connected pits are required as per IS 3043. And protective devices like MCBs, RCCBs and fuses safeguard circuits by interrupting fault currents and isolating faulty sections. Next is voltage drop and protective device requirements. IS 732 limits voltage drop to 2% for light loads and 5% for power circuits. Each circuit should have its own MCB or fuse for protection. These devices trip automatically in case of faults, preventing damage and improving safety. Next is overview of IS standards. The major IS codes followed in residential wiring are IS 732 for wiring practices, IS 3043 for earthing, IS 554 for cables and IS 1293 for plugs and sockets. These standards together ensure safety, reliability and proper material selection. Now we will see the IS rules for residential wiring. First is separate power and light circuits. In residential wiring, IS 732 says that lighting and power circuit must be separate. Lighting circuits carry smaller loads like bulbs and fans, while power circuits carry high loads, supply sockets for heavy appliances. This separation avoids overloading and makes maintenance much easier. Second is for wattage for points. The standard wattage values helps us design circuit properly. Normally, a light point is 60 to 100 watts, a fan point is around 80 to 100 watts, a 5 ampere socket is about 100 to 500 watts, and a 15 ampere socket can take up to 1500 to 2000 watts. These limits prevent overheating and protect appliances. Third is minimum conductor size. As per IS 732, the wire size depends on the circuit load. For light circuits, we use 1.5 mm square copper wire. For power circuit, we use 2.5 mm square copper wire. The earth wire should be same size as the face up to 2.5 mm square and at least half the face size beyond that. This ensures safety and current carrying capacity. Now fourth is permissible voltage drop. Voltage drop happens when current flows through long wires, reducing the voltage at the outlet. IS 732 allows a maximum of 2% voltage drop for lighting circuits and 5% for power circuits. Keeping voltage drop low ensures that lights glow at full brightness and appliances work efficiently. Switchboard height from floor. Fifth point. Switchboards should be placed 1.2 meters and 1.5 meters from the floor. This height makes them easily reachable for everyone and also keeps them safe from water and accidental touch by small children. Sixth point is ceiling fan height from floor. According to IS 374, the blades of the ceiling fan must be at least 2.75 meters or 9 feet above the floor. This prevents accidents, improves air circulation, and keeps the fan stable while running. Seventh is casing capping distance from ceiling. In surface wiring, IS 732 recommend that casing and capping or conduits be installed 150 to 500 mm below the ceiling. This distance keeps wiring away from moisture near the roof and gives space for maintenance or adding extra line later. Now 8th is number of earth pits. For residential installation, IS 3043 specifies one earth pit for a single phase connection and two interconnected earth pits for three phase supply. Proper earthing provides a safe path for fault current and prevents electric shock. 9th point is for main switch and meter location. As per IS 732, the main switch must be located immediately after the energy meter. Both should be easily accessible. The meter is usually installed outside or near the entrance so that electricity officials can inspect it without disturbing the owner. Now 10th point is for circuit protection. Each lighting and power circuit must have its own MCB or fuse according to its current rating. This ensures that if a fault occurs in one circuit, only that part trips, protecting the rest of the house from blackout or damage. Now we will see the estimation cost for residential wiring by taking a simple example. So here we have an example from estimation and costing. The question says for a given plan of a room with 7 fluorescent lamps, 2 fans and one 5 ampere plug socket, we have to prepare an estimate of wiring material required for casing capping wiring. The wiring is controlled from the control board and the ceiling height is 5 meters. See, now this is the wiring layout and isometric view of the room. We can see the main board and there are two control boards, CB1 and CB2. Switches for lamps and fans are fixed on the boards. The supply lines are shown through casing cappings on the ceilings and walls. T1 and T6 are the tube lights. T1 to T6 are tube lights and F1 and F2 are fans. Now the layout helps us calculate the total wiring length by measuring the runs of casing and wire from one point to another. Now before we get into the calculations, there are some assumptions made. The assumptions are the ceiling height is 5 meters. The control boards CB1 and CB2 are mounted at a height of 2.5 meters. Tube lights and fan points are hung about 1 meter below the ceiling. These assumptions helps us estimate the length of casing capping and wire runs more realistically. Now we will see the calculation part. Now for circuit number 1, CB1 to ceiling height is 3.5 meters. CB1 to ceiling height is 3.5 meter. Length of casing on ceiling to connect T2 and T5 is 7.5 meters. See, the length of casing on ceiling to connect T2 and T5 is 7.5 meter. Length of casing from T2 to T3 is 5 meter. Length of casing to connect T3, F1 and T4 is 5 meter. And now adding all these distances, we get circuit number 1 total length as 21 meters. Now for circuit number 2, length of casing on ceiling from T2 to T1 is 5 meter. Length of casing from T1 to CB2 is 2.5 plus 3.5 meter is equal to 6 meter. Length of casing from T1 to T6, T6 is 5 meter. Length of casing from F2 to T7 is 2.5 plus 2.5 is equal to 5 meter. Total length required for this circuit is all these addition, that is 21 meter. So total length of casing capping around required is 21 plus 21 is equal to 42 meter. Now adding 10% for wastage etc. Total length is equal to 42 plus 4.2 is equal to 46.2, let's say 47 meter. Hence length of VIR wire required is equal to 47 into 3 is equal to 141 meter. Now we have multiplied 3 here because we need phase, neutral and earthing wire. So that's why we multiplied 3 here. Now this is the estimation table. We can also say this is a costing table. Let's go through a few key items. One ICDP main switch 15 ampere to 50 volts, that is for 250 rupees. Two KitKat fuses 15 ampere, that is for 50 rupees. 47 meters of T-code casing capping, that is for 940 rupees. 141 meters of VIR wire, that is for 423 rupees. Now these are the main components used for the wiring setup. Continuing with the table, 9 ceiling roses for tube lights and fans 54 rupees. 2 plug sockets for 20 rupees. 10 switches 250 volt 5 ampere is for 60 rupees. 2 control boards made up of teak wood is for 70 rupees. Screws, insulators, gaties and small fittings are also included with their respective quantities to complete the installation properly. We also include 10 meters of copper wire for earthing, that is for 150 rupees. Wood screws, rolls, joints and other minor fittings around 200 rupees are combined. Miscellaneous items like sand, cement and insulation tape are taken as a lump sum of 100 rupees. When we add everything, the total cost comes to be rupees 2,929 for this entire wiring installation. So by analyzing the layout and calculating the material quantities, we can estimate the total cost for the complete installation. This kind of estimation helps the electrician and contractors plan the required material in advance, reduce the wastage and ensure proper budgeting. So to conclude, following IS standards and a proper designing procedure is really important for safe and efficient residential wiring. When we plan carefully, assess the load and separate lighting and power circuits, we get a reliable system that's easy to maintain. Also, proper earthing and protection devices like MCBs, RCCBs make the installation much safer. In short, by designing as per IS rules, we ensure the wiring is not only safe today but also future proof for higher loads. Thank you.